Alhamdulillah Rabbil Alamin. Assalatu wassalamu ala Sayyidina Muhammadin wa ala alihi wa sahbihi ajma'in. Okay, we have 20 students. Okay, 20 students. I can see Ahmad Azhar, Ahmad Anan, Ahmad Ishad, Chu K. Swan, and the rest. Okay, I hope everybody on the computer. Yeah, everybody on the computer now, right? Hello, hello.
Yes, Prof.
Okay,
Yes, Prof.
Ahmad Ada, are you in the campus or at home?
I'm at home, sir.
Hello.
At home, okay. Sarah dekat mana? Where are you, Sarah? At home.
Hello, sir.
Yeah.
I am at campus.
Yeah, at home, in the campus.
Campus, sir. Campus.
Oh, okay, good, right. Chu K, how do you, Chu K Swan. Hello, Chu K Swan. Yeah, are you in the campus?
In the campus, Prof.
Okay, right.
Sir,
Now,
sir.
yeah.
I already gave you my letters that I can attend class today.
Okay, right. So why are you here?
Someone called me and then I attend the class.
Huh?
Someone called me to attend the class.
Why? Because
I
you gave
know.
me the letter.
I gave you my letters that I can attend class today.
So, but you are
Okay.
attending today.
No, I'm
So-
not attending. I inform you again.
Okay, right. Okay, then.
But
Okay.
thank you.
Thank you. Right. So let's go to lecture. Okay. Let me share with you the slide. Okay, let's share the slide. Okay. Oh dear. Yeah. On. I want to share with you knowledge representation. Okay, can everybody see? Right? Hello? Can everybody see the slide?
Yes, sir.
Okay,
Yes,
right.
sir.
Okay, now guys, the second topic of our course, which is knowledge representation. Okay? Let we do together on this slide by Vishal Singh. Okay? I took from slide share because it's quite simple to understand this slide. Yeah. Because this course is only introduction to AI, right? AI is the area of computer science focusing on creating machine that can engage on behavior that human consider intelligent. Remember our last week lecture, we cannot define intelligent directly, but we can define intelligent through behavior. Okay, through behavior, through what I call it attributes of what things can do. So you see here, engage on behavior that human consider intelligent. Yeah, and we discussed about understanding of natural language. Yeah, one of the characteristic to have intelligence is to be able to understand human language. Okay, animal have very limited animal language, not as complicated, sophisticated as human language. Okay, so we have discussed about artificial intelligence definition last week. Now, knowledge can be managed by knowledge engineering. Yeah, there is such thing as we call knowledge engineering. Yeah, which include knowledge acquisition. Yeah, knowledge representation and knowledge manipulation. Knowledge acquisition is how you capture, how you collect, yeah, together knowledge. Okay, you got to you go make survey, you go and make observation, you go and do your experiments. Okay, you go and interview people, and then you collect as much as possible knowledge you'll be able to capture. That is under the topic of knowledge acquisition. Then after collecting knowledge, how you going to store this knowledge in the computer storage so that the computer can understand the meaning of that knowledge. Okay, understanding, yeah. Therefore, the way, the representation, the coding, that how you store knowledge must make easier for computer, quote unquote, to understand the knowledge, right? And knowledge manipulation. After you store in a specific way, and then you can manipulate knowledge. For example, like you can ask a question and answer about the knowledge, the computer be able to tell you, okay, be able to give you the correct answer based on the knowledge that you already stored. And you can discover new knowledge, you can make inference, okay, you can prove theorem through that knowledge that you store in certain knowledge representation. Okay, so the topic today is knowledge representation. Now we go to the next slide. Oh, the next slide. Yeah. When we are talking about knowledge, there is they say hierarchy of knowledge. Okay, it start with data. Yeah, data. Today is Wednesday. Okay, today is Wednesday, and we have a lecture called artificial intelligence. Okay, we have lecturer by the name of Dr. Suzaima. So that is data. Information, when you link all this data together, artificial intelligence is a course in computer science taught by Dr. Suzaima. Okay, so that becoming a kind of information. Then further up, knowledge. Knowledge, what are the requirements for you to get your bachelor degree in computer science? 120 credit hours. Okay, and there are compulsory courses that you need to do, and there are elective courses, yeah, you need to do, right? So this is knowledge, knowledge of how to get degree in computer science, yeah, which is bigger than information. Next we come wisdom. Wisdom a bit difficult to store. We are not going to talk in this subject how to store, how to collect wisdom, okay, how to determine wisdom, how to store wisdom inside the computer. Now, maybe some of you who are cadet officer might be in dilemma, okay, whether you want to remain as a cadet officer and you get your bachelor degree in computer science with PNGK 2.7 and then make military as your career. Okay? Some of you, yeah, since beginning have dilemma whether to be a cadet officer or not. Yeah, when you become cadet officer, of course, you get a lot of money every month. Yeah, there is a salary they pay you, but you got to work. Yeah, military regiment. Yeah, you got to do extra work, training, beside just doing academic work. Okay, so that depends on your wisdom. Yeah, whether you want to continue to be a cadet officer, or you want to leave If you leave, then you got to pay penalty for leaving, breach of contract. So that depends on how wise you are to decide whether to go on or not, and depends on the circumstances, yeah, in the situation you are in, yeah. If you need money so much because you are from kampong and your family doesn't have much money, maybe it's wise to stay on. Okay, but you are some fellow from town and from rich family, maybe you don't want to be in a military war. Yeah, but if your ambition to be one day a general, Panglima Angkatan Tentera, maybe that's a good choice also. So that depends how you think, and depends on your belief system. That is wisdom. Okay, talking about wisdom, we take example of a drone. A drone can be a very efficient and effective killer machine. Okay, you send drone to war, operated by drone pilots, yeah, thousands miles away, and you send a drone to kill people, to bomb, to go and bomb places. Yeah. So the question now: Do drones have wisdom? Who to kill? Yeah. If drone doesn't have wisdom, I mean drone will kill children's, will kill women's, yeah, non-combative citizens, yeah. Drone will kill animals. Drone will destroy environment, plant, tree, and whatnot. Okay, so now I go to. So the question is how to store wisdoms, yeah, in the computer. Any of you has seen the exercise that are given to see as the film Transcendence? Anybody have seen that film? Transcendence, starring Johnny Depp. Hello, hello. Hello, are you there?
Yes, Prof.
I'm there.
Anybody have seen the film?
Yes, Prof.
Yes, Prof.
I have not been able to find all these.
Okay, right. If you see the film, then you can understand what I'm talking about. Yeah, until become wisdom. Yeah. So when the computer achieve singularity, yeah, in that film mentioned the word singularity. Yeah, when computer achieve singularity and achieve artificial super intelligence, yeah, then the computer will learn by itself. Maybe computer will have wisdom or not. It depends how you program the computer, whether you implant the belief system, the wisdom set the computer or not. Okay, so one day it's possible for a computer to go to that level, not only artificial intelligence but also artificial wisdom. Okay, artificial wisdom that computer mimic a human being, the wise human being. Okay, there is a hierarchy of knowledge. Now we go further. Type of knowledge. It listed here two type of knowledge. One, domain dependent knowledge. Another is domain independent knowledge. So to me, domain independent knowledge are those knowledge that is general knowledge. Yeah, general knowledge. For example, like given a name Fatima. Okay, Fatima's the gender, yeah, of Fatima, male or female. Of course, yeah. In our world, Fatima always a female. That is domain independent knowledge. Yeah, just an example, right? And domain dependent knowledge, for example, like classification of student. Let's say classification of student in UPMM, we have 3 classification of student. Yeah? Unlike other university, we have cadet officer, we have pelapis, and we have civilian, yeah, who doesn't belong to cadet, yeah, and doesn't belong to pelapis. So in other university, maybe they don't have this classification of student. So it's domain domain dependent knowledge, and also it's also related to the field of, for example, in the field of accounting, as opposed to engineering. So they have different domain dependent knowledge. Okay, so there's 2 category over here. For a computer to be intelligent, it should have domain independent knowledge, okay, as well as domain dependent language. Domain dependent knowledge. Just an example, just now, female. Yeah, Fatima is a female. Computer should know that. If not, yeah, computer is not very clever, right? Hello, 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 hello. Okay, now choosing a representation. Yeah, there are few technique how we can store our representation. So it depends on our choice. In this slide, it say that for certain problem solving technique, maybe best representation already known. Okay, that means it depends on the problem that you want to solve. Yeah. For example, yeah, you know the system called genealogy, okay, of people, yeah, who the son of who, yeah, who the husband of who, so GENI, yeah. So in this system, maybe the best way to store knowledge is using graph. Okay, but a problem to mathematical problem, yeah, to solve mathematical theorem, yeah, maybe it's good to present the knowledge in the form of logic. Okay, we will have a look at how this knowledge representation will look like. Often a requirements of the technique, what does it mean here, or a requirement of the programming language. Okay, it also depends on the tools, programming tools, the language of the system tool that you use will also determine, yeah, what kind of knowledge representation that you want to use. Take for example Prolog, yeah, programming in Prolog. Programming logic. Prolog stands for programming logic. Therefore, in Prolog, yeah, you present your knowledge in terms of logic. So, example here, first order theorem proving. There is you use logical method. Yeah, first order logic, logic programming. Or you can use neural network learning and neural net. So there is another neural network. So neural network, how you store knowledge, okay, different from other because it's a machine will do the learning by itself. Yeah, maybe you need to input some feature into a neural net. For example, face recognition. Most of the people they use a neural net. Okay, face recognition may be the way they put information is to calculate the distance between your eyes, and then the distance between the tip of your eye to the tip of your nose, and the tip of your nose, yeah, to your chin, yeah, and the distance of your eye to your ear, okay, yeah, the base of your ear. So there is a feature measurement that they use to input into a neural network for learning and to recognize people, for example, right? And also some general representation scheme. This is maybe other than commonly known representation. You might devise yourself. Okay, in this lecture, we need to concentrate on three type of knowledge representation. Number one is logical representation. Number two is production rule. Yeah. Number three is semantic network. Semantic network comprises of two techniques: conceptual graph and frame. Okay, so we just concentrate on these three classification of knowledge representation. So we move forward. Logic. Okay, I don't want to explain the basic logic, yeah, because you have taken the course discrete mathematics. Yeah, in discrete mathematics, you were taught about mathematical logic. Yeah, logical expressions, Boolean algebra. All right. So they say that the advantage. Let's see what you say here. A language with concrete rules, because since logic is based on first order predicate logic on mathematics, therefore, yeah, the rules are quite concrete. Yeah, no ambiguity in representation, allows unambiguous communication and processing. Right, very unlikely natural language. Very unlikely natural languages, for example, English. So yeah, that shows some advantage of logic. Many ways to translate between languages. A statement can be represented in different logic and perhaps differently in same logic. Okay, expressiveness of a logic. How much can we say in this language, not to be confused with logical reasoning. Yeah? Logic are languages, reasoning is a process. Yeah? May use logic. Okay, logic are languages, and reasoning, yeah, based on the logic, yeah, we can do reasoning. Yeah? Reasoning is the process how to derive answer from the knowledge base. Okay, let's go forward. Yeah. Okay. In any languages, be it natural language, Malay, English, Chinese, and be it computer languages, we have, yeah, syntax and semantic. Okay. What does syntax mean? Syntax are symbol or words, and the grammar, the rules how to join words, symbol together. That is syntax, right? Semantic is the meaning of sentences. Given a sentence, what is the meaning? Okay, how you interpret it. So this is the simple definition of syntax. Syntax are symbol and how you join the symbol and grammar. Yeah, grammar teach you how to join words together. Yeah, for example, in Malay, ayat nama dan cerita. Ya. Ayat adalah nama diikuti oleh cerita. Ahmad main bola. Ya. Main bola itu cerita. Okay, that is a syntax. Ya. Ya, ya, ayat ya, is defined as nama, subject followed by cerita, predicate. Ya. Ayat adalah subject diikuti oleh predicate. That is syntax. Ya. Kalau main bola Ahmad dah salah dalam bahasa grammar Melayu, nahu Melayu, bermain bola Ahmad. Ya. Tetapi bahasa Melayu sintaksnya ayat adalah subjek ataupun nama diikuti dengan cerita. Alright. Kalau bahasa Arab pula, ya, predicate dahulu kan, baru diikuti dengan subjek. Ya. So itu apa yang dikatakan ya syntax. Then we go to semantic. Yes, semantics adalah is the meaning of the sentence. How we interpret or how do we read sentences in logic or in any language. Assign a meaning to each sentence. As for example, all lecturers are 7 foot tall. So these are English symbol words. Yeah, all lecturers are 7 foot tall. Okay, so the meaning of this, you know, everybody of you knows that what it meant. That means all the lecturers are so tall until all of them 7 foot tall. Okay. Now, in terms of syntax, in terms of is valid, valid sentence. In terms of syntax, well-formed syntax, valid, and we can understand the meaning. Measure all lecturer, the height of all lecturer. Everyone should be 7 foot tall. Okay, we know the semantic of it. Okay, but the truth value, the truth value of this sentence, true or false? Anybody can answer the truth value of this sentence? All lecturers are 7 foot tall. Hello, 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 hello.
Hi, Prof. Yeah.
True or false?
False.
False. Yeah, it's false. Okay. Okay. So just to give the meaning. It's like over here. Okay. Yeah. So now we understand what is syntax. Okay. What is syntax and what is semantic. And what is truth value. Okay, the truth value. Any sentence, there is a truth value to it. So all lecturers are 7 foot tall. That is preposition. Okay, which is false in the context of UPMF. Right. So we go further. Okay, in logic also you have syntax, you have semantic, and you have truth value. Okay, in logic the truth value is 0 or 1, yes or no. There is, unless you go to multi-value logic, they have several values, not only 0 between 0 and 1, but also have other value, maybe 0, 0.5, and 1. It can be fuzzy. That is we go into the fuzzy logic. So now, propositional logic. Example of propositional logic this is sentence. All lecturers are 7-foot tall is example of a sentence in propositional logic. Yeah, whereby propositional logic there is no variable. Okay, there's no variable. Again, the syntax, the grammar, how you combine symbol. This proposition, propositional logic comprises of proposition. Proposition, for example, it is wet. Okay, there is a proposition. 7-foot tall. Yeah, there is proposition. Okay, just words. Yeah, today is raining. Today is raining in UPMM. True or false? It's false. It's not raining today. That is proposition, right? And then proposition. Today is Wednesday is a proposition. And this symbol N. Okay, symbol N here, and it is raining. So it will be false. Today is Wednesday is true, and I mean logical and this operator and V inverse V, and today is raining. Today is raining is false. Therefore, true and false is false, right? You learn that in logic, right? So that is propositional logic. And then today is Wednesday. You can give the symbol P to that proposition. Today is raining. You can give a symbol Q to that proposition. If you ask P and Q, the value is true or false. Today is Wednesday, which is P, and Q. Q is today is raining. Okay. Today Wednesday is true, and today is raining is false. True and false is false. Okay. Just simple. Just refreshing. Refresh your memory on logic. Propositional logic. Then we go to higher level of logic. Higher level of logic, we call it predicate logic. Okay. So predicate logic, you can assign variables. Yeah, we can assign variable to object. Okay. Now, propositional logic combine atoms. Yeah, combine atoms. Atoms are proposition. Yeah, atoms are proposition with connective. These are this connective, and or not imply equivalence. Okay, so everyone of you have done that before. Now, let's go to a bit higher logic, which is predicate logic. Okay, we have predicate logic, and before that we have propositional logic. Okay, predicate logic is more powerful than propositional logic. Okay, because you can use variable in this logic. For example, like predicate allow us to talk about object. Predicate logic. And give properties to is wet is a property, is raining is a property. Okay, and also in predicate logic you can spell out relationship between object. John and apples are two objects. Okay, what is the relationship between John and Paul. Yeah? Relationship is likes. John likes apple. Okay. That means John likes to eat apple. Yeah. So I I repeat. Predicate logic. You have property that you can describe predicate logic. So this predicate logic you can use to store knowledge. That's why it is known as knowledge representation, logical knowledge representation. Okay. In predicate logic, each atom is a predicate. Yeah. Basic structure called atom is a predicate. This is a predicate. Is wet today is a predicate. Okay. Is wet today is a predicate. John likes apple. Likes John apple is a predicate. We can use this representation, to store as a knowledge-based representation. Now, in predicate logic, we also have this. We only want to do first order logic. Yeah. The above example is first order logic. Okay. We don't want to go to higher order logic. Higher order logic, they are more powerful logic. Yeah. We just want to do first order predicate logic. Okay. Go next. I hope everybody can understand. Very simple concept. Yeah. Very straightforward. Now we go further. First order logic or predicate logic. Yeah. Simply called predicate logic. First order predicate logic. More expressive logic than propositional logic used in this course. Right. Okay, you have constants. Yeah, you have constant. You have predicate in this logic. You have function. Okay, you have variable. Yeah, variable and quantifier. Okay, quantifier for all x that exist at. Yeah, A terbalik and E terbalik. Okay. A upside down stand for all x. Yeah? X like apples. That means to say that for all monkeys like apple. There exists X, there exists a tiger, where X, tiger like apple. Yeah. So so we have constant, we have predicate. Yeah, we have predicate. Yeah. So over here, like John Apple, the name of the predicate is like. Okay. So the whole thing is known as predicate. Yeah. So you have the predicate names like. Yeah. We have two arguments, John and Apple. Okay, two arguments. So predicate can have one argument or more than one argument. Okay. If you look at the first, yeah, here, this is predicate with one argument. Yeah. One argument is today, only one. Over here, argument, there are two arguments, John and Apple. Okay. The name of predicate is wet. Is the name of predicate is like. Okay. And you can have predicate with more than two. Yeah. More than two arguments. All right. So this is basically. Okay. So this like simplify everything. Yeah. Yeah, that's why I choose this slide for teaching you all. Okay. Now, first order logic sentence. This is example of first order logic or predicate logic sentence. In natural language, you say every rose has a thorn. Okay, how you can translate this sentence into logical expression, into first order logic. Yeah? Every rose, therefore, you say here for all x, yeah, for all x, yeah, x is rose, yeah, that exists y is a thorn, and x has y, x has thorn. Okay, very simple. Okay, we say here if x is a rose, then there exists y, x has y, and y is a thorn. Yeah, so that's a in predicate logic, it looks like this. Yep. The equation, yeah, like this. If you translate into prolog, we will see later, it will look like this. Okay, for all x, yeah, if x is a rose, then there exists y, yeah, x as y, and y is a thorn, yeah. So I go slowly. This is no need, yeah, you read by yourself. Okay. Okay, we're not going to do higher order logic because higher order logic is more powerful. For example, here the predicate name F0, okay, F0, predicate name can be variable. Yeah, in first order logic, predicate name cannot be a variable. Okay, we will explain later. But don't bother about this idea. Yeah? Higher order logic. Yeah. In first order logic, the name of the predicate cannot be variable. Yeah. So over here, the name of predicate in second order logic, the name of predicate can be variable. Okay. Now, multi-value logic. Okay, we only deal with Boolean logic. Yeah. Model logic. We are not going to deal. We're going to deal with it. Yeah. It's more complicated. Okay, I'm not going to touch you here. Now, logic is a good representation. The things addressed in this slide is that basic for programming languages. Yeah, for example, Prolog. Okay, Prolog uses logic programming. Okay, based on logic. And Lambda Prolog for higher order logic, yeah, because of the lambda here. Lambda means a variable lambda. We call lambda prolog. Okay, we're not going to. We go to okay. We have touched a little bit, yeah, on this logical representation. Now we're going to other representation, non-logical representation, the production rule. Production rules and semantic network. Logic representation have restrictions and can be hard to work with. So therefore, it worthwhile to also look at other representation. Now, let's say production rule. Okay, production rule. The format of production rule is condition action. Yeah. So all of you know how to program. Therefore, you know this statement: if condition, then action. Okay. So for production rules are based on this format: if, then, else. Okay. Or to be short, if condition, then do the action. All right. I'm not going to. Okay, go to the example here. If at bus stop and the bus arrive, then the action is get on the bus. You want to program a robot. Robot, you ask the robot to wait at the bus stop. Okay, therefore you should program the robot saying that if you robot at the bus stop and the bus arrive, then you should go on the bus, right? So this is knowledge representation written in production rule for robot to follow. Another example, if on the bus and not pay and have Oyster card. Yeah, Oyster card is just a season card. Season card where you used in UK. Yeah, a season card you buy monthly card. Okay, therefore you no need to pay, and you have because you have season card. Then action is pay with Oyster. Okay, you pay with Oyster card. Yeah, your credit card. Yeah, your debit card, and add pay. Okay, so that means to register you already pay. If on the bus and pay and empty seat, then sit down. So these are three rules, yeah, to program the robot. Okay, how to ride a bus. Yeah. Therefore, you represent this knowledge in the form of rules for robot to follow. All right. So very simple. Yeah. If then, condition and action must be clearly defined. Yeah. Now, there is number two. Type number two of knowledge representation, which is production rules. Number three, graphical representation, because it is easy to draw sometimes. Okay, so you this is a neural network. Yeah, neural network diagram. I think this example is much better. Okay, this graph, graph representation. For example, like this, the name. Let me. I don't want to. Right. Okay. We have three people over here: Otter, Jim, Brian, and Jackson. Okay. We have four nodes. Represent four person, four nodes. And what are the relationship between those people? Yep. Otter is the father of Brian. Brian is the father of Jason. And Otter is the brother of Jim. Okay? That means you have node which represent object. Okay? Node which represent object. And we have relationship between those objects. The relationship in the form of father, brother, father and brother. Okay, you can have any kind of relationship that you can define. Right. This is another example. Relationship are mother, sister. Yeah, and you have five people over here. Ida, Madrid, Julia, Jane, and Jason. Okay, right. So these are the semantic network. Okay, because the syntax is the same, two syntax. Okay, we can guess that Julia is similar to Brian. Yeah. Anyway, I'm not going to discuss that. So we have semantic network. Semantic network, graphical representation using graph. Yeah, we have a link indicate relationship. Okay, so this relationship can be relationship indicate subset, members, or any relationship. Yep. Cadet is a subset of UPM student. Pelapis is a subset of UPM student. Yeah. Ahmad is a member of UPMM student. Yeah. Relationship. Okay. Ahmad and Fatima, they share the same class, taking the same course, right? So, right. I go for the conceptual graph. Semantic network where each graph represents a single proposition. Yeah. So this another semantic representation whereby ages do not have labels. Yeah, John, James, yeah, John, James, and Jack. Okay, the link doesn't have any label, but it's linked by oblong here, oval shape brother. So that means relationship is brother. Okay, they call it conceptual graph, almost semantic network, but the convention of writing is different. Okay, the label you don't put a label on the arrow. Okay, over here you put label on the arrow. Okay, the nodes are all object. Yeah, over here the nodes, the node object or relationship. Okay, so you change the convention a little bit and you name it as conceptual graph. Okay, now frame. We come to frame. Lastly, we come to frame. Okay, semantic network where nodes have structure. The node have structure. When nodes have structure, you know the node here, the node, yeah, node here. Author Jim, yeah, Brian, Jason, they are nodes. There's no structure here. But if node have structure, for example, like Jim have 2 legs. Okay, age of Jim is 33 years old. The height of Jim 6'2". So if you want to put extra information on the nodes, then you use frame. Okay, I will show you an example of that. So therefore, yeah, if the nodes have been structured, then you use the concept of frame to represent the node, whereby the nodes having the name of the person, the age, and the height. Okay, get the node. Each slot store specific item of information. Okay, or this age, height, we call it slot. Yeah, we call it slot. When agent faces a new situation, a slot can be filled in. Value may be another frame. Yeah, filling in many may trigger action, may trigger retrieval of order. Okay, let me give you by example. All right, this lecturer, yeah, lecturer here is a frame. It's a kind of frame. Yeah, you define a lecturer as a frame, and lecturer, under lecturer we have name. Yeah, we call it slot. Yeah, slot. Slot we have filler. Okay, so value. Yeah, tolerance is another slot. So the filler, the blank that we can fill is intolerance. That means this lecturer frame you can put here. You can put here Jim as a using the frames. Frame to represent Jim. Okay, so the name of this frame is lecturer, and the name here is Jim. Okay, And now you say this lecturer, intolerance or not. If intolerant, then turn off mobile phone. So this lecturer, Professor John, doesn't like to see his student using mobile phone during classes. Yeah, and also you must pay attention. Yeah, if Professor John is intolerant, then pay attention. Okay, if not, he will chase you out of the class. Right? So very easy. Okay. Non-representation Propositional Logic. Okay. So yeah, it's a flexibility in frame. Slot in a frame can contain information for choosing a frame in a situation. Relationship between this and other frame. Okay, procedure do carry out after various slot is filled. For example, here, okay, if intolerant, then turn off phone. Based on the values in the slot, you can do the action. Okay, I think roughly I have introduced to you, it's already 1 hour. Okay, I already introduced to you 3 types of knowledge representation. Okay, 3 types. Yeah, first is logic. The first is logic, then followed by production rules, and then followed by the semantic network. Okay, very simple. Okay, that's much I think you need to know. If you don't understand, go and find books that discuss on this thing. Okay, very simple. When we talk about knowledge representation, you only supposed to know logical representation, production rules, and semantic network. Okay. Now I how you use logic. Okay. Now how you use logic. So go here. Okay. You can find on. Okay. Can you see? Can you see this prolog family tree? Hello, hello.
Yes, Prof.
Hello,
Yes,
hello.
Prof.
Okay.
Yes, Prof.
All right.
Yes, Prof.
Okay, this is example of logical representation using prolog language, right? Now you see here. Oliver, Ali, James, Simon, right to Lily, so they are object. Yeah, that means to declare the fact. Declare the fact that Jack is male, Alan is female, and so does the rest. Okay. So this is in predicate logic. Now, next, parent of is another predicate. Yeah, having 2 arguments. Yeah, Jack and Jess. That means to say the the interpretation of this and the semantic of this, Jack is parent of Jess. You can interpret otherwise. You can say Jess, yeah, Jess is a parent of Jack. Okay, but you must decide which convention you want, which interpretation you want to use. So over here, we use Jack is a parent of Jess. Yeah, Jess anak dia lah. Yeah. Over here, Jack is a parent of Lily. Yeah? Lily anak dia lah. Not otherwise. It's not just anak Lily. Yeah? So it depends on your usage, but you must be consistent. Yeah. So we have this. Yeah. Three predicate. Yeah? Male, female, and parent of. Parent of. These are the fact, yeah, in your database, right? The fact in your database. Now, I'm not going to go to the rules yet. Okay, not going to the rules yet. I'm going to close this first. Close this first. And where should I go? I close this first. What next I want to do is I want to go to prologue system, which is, let's see this one. Okay, so there is a prologue interpreter. They call SWI. Okay, SWI. Can you see this SWI? The R, yeah.
Yes, bro.
Yes,
Yeah?
you can see, Prof.
Yeah, SWI prologue. Okay, I want to execute this. So one of your assignment is to go and download SWI prologue. Okay, I click that. So this is a prologue interface. Okay, yeah, can you see prologue interface SWI prologue? Okay. Now I have a program written somewhere. I'm going to go and edit that program. Okay. This, I store somewhere as prologue family tree. Okay. Yeah. Okay. Can you see this program?
Yes, sir.
Yes, bro.
Yes.
Okay. Okay. I already written this program. Having male, female as predicate, parent of as predicate, which are the fact in your knowledge base, and followed by the rules. I'm not going to touch the rule first. Okay. So now I go and compile it. Compile. I use compile in buffer. Yeah. Don't ask me so much about this because I'm just learning how to use SWI prologue. So you go to compile. Yeah. You go to compile. Compile this program into buffer. Okay. That means this program will already goes into the prologue system. So go back from your program file to to the SWI environment, which already have the knowledge that you declare. Now I want to ask question, to list down all persons who are males. So male X. X is capital X. Capital X means variable. In prologue, anything begins with capital letter, it means variable. Okay. Therefore, males over here, predicate male cannot be written with capital M. So I enter, I get the first answer. X is Jack. Okay. I want to have more answer, all the answer. I press semicolon. Okay. I press semicolon means I want more answer. Okay. X is Oliver. Press semicolon again. X is Ali. Press again. X is James. Press again semicolon. X is Simon. And X is Harry. Then it stop. It give me the query prompt. The question mark. The question mark prompt. Any question you want to ask? Yes. I want to ask. Okay. Okay. Male. Okay. Specifically, okay, is just a male. You say no, it's false. Okay, false mean no. Yeah. Specifically, I want to ask: is Oliver is a male? Yes, true. Yeah. I want to list out female. We capital letter. Okay. Anything. Okay. Is a variable name because it starts with capital H, M, 899. Okay. Full stop. Yeah. Must end with full stop. Alan, Sophie, Jess, Lily, Fatima. Right? So you got the graphs of this what it's all about. Yeah. This is the fact. Now let's go to the yeah. So remember, yeah, we discussed about the fact male having one attribute, one argument, and then we have parent having two arguments. So that means to say that any predicate, yeah, can have more than one argument. Okay. Now we go to how to write rules. Yeah. How we can write rules in Prolog. Yeah. So this also can be seen as a production rule. Yeah. Yeah. Because it's a rule. One of the number one we say logic representation. Number two we say production rule representation. So this is both. Yeah. Logic as well as production rule representation. Now, this in the middle here, yeah, the middle here is column followed by dash. Yeah, it can be read. Yeah, it can be read as if. Yeah, column followed by dash. Can be read as if. Yeah. So how you read and how you interpret. Yeah. The meaning of this rule is that X is father of Y if, okay, if the right hand side or the right hand side are true. X is a father of Y if X is male. Yes, to be a father, you got to be male. Yeah, X is male. This comma stand for N, logical N. Yeah, logical N. Yeah, logical N. True and true is true. True and false is false. So this comma is logical N. You might ask, what is OR? Logical OR. Logical OR is semicolon. Okay, logical OR is semicolon. Comma is logical N. So X is the father of Y if X is male and X is parent of Y. So the word parent of here can be male or female. Okay, parent can be male or female. When parent is male, we call it father. When parent is female, yeah, when X is female, we call it mother. Okay, so it's quite easy, okay, to declare rule in Prolog. Yeah, it's quite easy and quite is by definition. Yeah, this is what we call declarative programming. Yeah, it's not procedural programming, but declarative. Yeah, you declare. Yeah, you declare the attribute of things. Yeah, now you declare to be a father. Therefore, X to be a father of Y, X must be male. X to be a mother of Y, X must be female. Yeah? And X must be parent of Y. Yeah. Now we go another one. Grandfather. Yeah. Grandfather, of course, grandfather must be male. X is grandfather of Y. Therefore, first of all, the rule is X must be male. Then X must be parent of Z, and Z is parent of Y. You see the transitivity here. Okay. Therefore, X is grandfather of Y. So you must have somebody in between, which is Z. Okay, somebody in between which is Z in order to be grandfather. Okay, Z is parent of Y, and X is parent of Z. Therefore, X is grandfather of Y. Okay, that's how you write the rule in prolog. Okay, these are all comment. Percentage, and by percentage they are comment. Don't need to. Okay, let's go to sister. Sister. Okay, sister. It says sister X and Y are sister. X sister of Y. Yeah. Forget about this because this is just a comment line. X, to be a sister, X must be female. Okay, to be a sister, X must be female, and to be a sister, X and Y sharing the same father. F is the father of Y, and F is also a father of X. Okay, and here you put another condition: X is not this slash sign here. X is not Y, not the same person. Okay, they are not the same person. Aminah is a sister to Aminah, sister to herself. No need to mention. So X is not equal herself. Yeah, X is not equal to Y. Yeah? So to be a sister, you must be female and you must share the same father, or you must be female and you share the same mother. So that means you are sister. Okay, and so forth. You can read and understand by yourself. Now, so we have this. Then we can go back to prolog environment and ask question. Okay, parent of. I want to list why they are parent to one another. Okay, Jack is parent of Jess, semicolon. Jack is parent to Lily, Helen is parent to Jess, Ellen is parent to Lily, Oliver is parent to James, Sophie parent to, and so forth. Okay, so forth. Ali is parent to Fatima. Okay, I can ask for the grandfather of X and Y. Instead of X and Y, you can call it A and B. Okay, full stop. Right. So you have all the answer over there. Yeah, you have all the answer there. So it shows how easy to use this language, logical language, to represent your knowledge representation. Yeah, your knowledge base, to declare your knowledge base. So these are knowledge base about family. Okay. Now I think we should stop over here, but I also have assignment for you, yeah? Assignment which I posted inside e-learning. Okay, let's go and look at the assignment. Okay, let's look at the assignment. Yeah, go back here. No. share with you. Assignment 1 I've given to you already. Assignment 2. Assignment 2. Where is assignment 2? Assignment 2. Okay. Okay, this is your assignment 2. Can we see download and install SWI Prolog. Use Prolog program family tree given in this lecture to add more fact to register brother, sister, aunt, and uncle. Yeah. Okay. File name extension for Prolog program is PR. Okay. And to write Prolog program, you use Notepad. Yeah. Don't use words. Yeah. You use Notepad because you need to have just a character text form. Yeah. Because Word having lot of HTML notation. Yeah. Okay, consult the program using consult or edit. Yeah, consult. Consult. Oh, stroke. Oh, dia buat stroke. Edit the program using SW1 Prolog and make some queries. And then there's an exercise for you. Make a survey of 10 shoes. Okay. Yep. Having those attributes and write Prolog program for it. Latest date is the 5th of April. Okay. Good luck. Yeah. Okay. Any question? Any question?
Prof,
Yeah.